Yeah, good afternoon. Some really good presentations today. I think that's the most I've ever learned about 3D piping, so thanks for that. So we're both from HDR, Matt Goldsberry. My background is design and architecture, and then I kind of shifted into computation and digital practice over the course of the last 5 years. I think mainly because my interests have been in sort of limits of software and being able to extend those limits in a lot of different ways. And then my previous life did a little work in special effects, so I kind of have a lot of design background and some visual background as well.
Yeah, my background, I've been at HDR for almost 5 years and was a project architect for a few years, transitioned into now a computational design role. My background before coming to HDR was a private high-performance building consultant, so very much balancing design and performance in a variety of different ways, and I think the computation kind of bridges the gap between a lot of these things and provides a common language for this. So just to speak a little bit about the obligatory company slides, this is showing sort of, it's not the most up-to-date, but it's showing just the broad scope of where our offices are located, and we have key design centers across the world with computational talent located in each of those design centers. One of the things to focus on is just the sort of the breadth of the work that we do. We kind of touch all sectors, and Matt and I are constantly looking for ways to bridge the work we've done in each of these special groups using computational design, kind of looking at the overlap between them all. So everything from small workplace all the way up to 4 million square feet healthcare projects all across like the Middle East and the U.S. and Canada and pretty much everywhere.
So one of the themes kind of going on this morning was this idea of BIM and computation not being a tool or a technology, but being a process and mechanism for communication. So to illustrate this, kind of the way we talk about this, kind of a reflection on how our industry works. There's kind of two problems that I want to show kind of as an illustrated comic, but two main problems that we see. One of them we call the traditional method, and I think everyone here can probably relate to this. So this is the classic scenario that this is everything's kind of getting handed off. So you have the black cape architect on the left, handing it over to the intern people, saying, I got this big idea. Can you put these into your CAD machine? And the guys are like, I don't even know what a CAD machine is anymore. And then they're building away on the model, doing all day, all night working on the model, and then the black cape architect comes in and says, he's got a design change and wants to go vertical. And then it gets pushed off into the Department of Construction documents, and the designer has no idea what how much it costs until it can get run through the.
It's a very siloed process. I mean, nobody's really communicating. It's just handing off things. There's no cyclical feedback.
So kind of skipping forward here into the hurry up and wait. So this model is that we're all using technology, but we're not quite sure exactly what we're doing. We're just kind of jumping onto the projects all at the same time really fast. And so what tends to happen is that everyone jumps on, and then nobody has anything to do because they're always waiting for something from somebody else. So you can't update, you can't do the plan until you have the design. You can't do the design until you have the program. You can't do the program until
you have the meeting that determines the design and the program and everything else. So it's, again, siloed, or almost everybody's in one silo, but nobody has the right information.
And then when it gets towards the end of the project, everyone's kind of blaming each other, and you're making these radical choices like, change it to EFIS to save money. Nobody work until, structure updates the model. And then you have that classic thing of I think I saw this earlier on a slide, but the final save, has the final save been done yet? You got one more change.
And which version of the final save are we in?
Yeah. And then the project should be built, but it's not, so it's overdue, and then everyone's blaming each other.
Or the architect.
So rather than, this comic strip kind of goes on for a while, and we we could probably talk about that for the whole
That could be
30
a
minutes.
30-minute
But
presentation.
the third version is what we're actually been doing I think, in computation, which is how it hopefully kind of connects a lot of those different parts together. So Project X, nothing too secretive, but this is a project in Omaha, Nebraska. It's a mixed-use project, fairly small scale for a lot of the projects that we typically work on, but we do a lot of projects this size. Retail at the base, office space up above, multi-tenants. And then there's 3 different buildings. So one of the things we're kind of skipping out in this whole presentation is the process to get to this design. So the design is fairly simple. It's got a couple angle cuts to it, and that relates to the buildings around it. So do we get into? So just getting into like the massing. So in order to create one of these models, you have to have the idea of how, what are the driving principles of the design that are going to drive how the building's going to flux. And I think we saw earlier, I think it was Santiago gave a really good kind of presentation about how these models work. And these models work great for us, but one of the things we're really interested in is kind of taking these models and kind of going beyond these models.
Not just focusing on the formal aspect of it, because that's, while that's very important to kind of translate a lot of this design intent back into any sort of production software if we want to get into interoperability and understanding, but really start bringing on an additional level of analysis that comes with this. So it's not just looking at the formal part of it, it's actually looking at all the bits and pieces that go into a building.
So like I say, one of the things we're interested in is user interfaces and user experiences. So whenever you talk about that, you tend to think of Tony Stark and these crazy interfaces. And on one hand, this is you could think of this as the future, but in the other, this stuff exists now. So we have the HoloLens. We can do augmented reality and edit models with it. It's not quite mainstream, but the technology is already developed for it. User interfaces, we'll show another one that's a little bit more practical after this, but this stuff exists now, so it's not even like we're predicting the future.
Right.
So,
this isn't 20 years out. This is, 20 months out or something like that. And depending on who you talk to from Autodesk, could be available in 2 weeks. But one of the things we sort of taken a step back and looking at some real world examples that are currently out there and looking at other industries, right? So aerospace has taken this idea of these dashboards and heads-up displays to provide information feedback, and we're looking at the similar thing but for building. So you have the speed limit, which is sort of your baseline or your constraint, and then your performance is measured against that, as well as additional layers of information, turn-by-turn directions, other things like that. We can take that same approach for data visualization and display within our interactive design models. I think it provides a real opportunity to get feedback to the designers in almost real time.
So before we jump back into the original project we're going to talk about for the presentation, just showing some of the dashboards and user interfaces that we've created on some previous projects recently. So some cloud-based dashboards, Tableau, Power BI, and then pulling that information into Rhino and Grasshopper environment just to visually look at the information. So it's just automating large program elements. This is Gephi, a free physics-based engine for adjacency studies. So this is like a huge mega program and kind of looking at potential adjacencies.
In another industry, this would be called like social network analysis. Predictive analytics uses a lot of this to understand connections between parts and relationships.
So then taking that same information and pulling it into Rhino, instead of using that information to build spaces, using it to build three-dimensional charts and graphs. So here we're looking at the rooms and the rooms on different floors, and then how those rooms overlap to see which rooms might overlap between the different buildings. And then I'm going to skip over this.
This is starting to look a bit more at, the design massing phase, but then starting to introduce additional levels of complexity and practicality. So we need a center core for this space, starting to looking at, now we're visualizing these floor plates. And what you're seeing is actually not 2 separate screens that we've recorded. This is a simultaneous model. So that is a heads-up display that's actually showing in real time what the design changes are being made. So what you don't see are the grasshopper sliders driving the massing or the core size, but what you're getting is a real-time understanding of what that impact looks like from a square footage and a floor plate size. You can begin a better understanding of your programming.
So when we're meeting with the team, especially the client, and we start shaving off square footage, and he doesn't really like it, we can start to see what's going to be too much.
It's layering that level of information, feedback, and graphic knowledge, so it provides a good balance of both. We actually start to roll that into, this is a structural dashboard, so to speak, and we're starting to look at different structural options that match each of the massing options. So if we use the parametric model, we come up with 5 options we want to study, and then we can start applying a structural system to that. And what you're seeing in the charts and graphs are breakouts for tonnage, linear square feet, columns, any sort of specialty space, and we can start actually rolling that into, and an integrated project delivery becomes really important because we can actually get the contractor's feedback or any of our sub feedback in to actually start pricing this stuff as early as possible and getting just a better understanding of the logistics behind a lot of this coordination, which becomes really valuable.
Yeah, so on this project, one of the big things with the client and then our end was that how much angle can we get before we add on too much steel structure and we're losing too much square footage, so kind of that balance between those two variables. So 2 big things that we deal with on every single project is people and cost. So first we're going to talk about people. So always wanting to have more people that fit in the building. So that, in a lot of ways this is a very simple tool. It might be kind of hard to read, but it's an Excel doc on the right, and then on the left is just an open modeling space with the similar information that's on the Excel onto the modeling environment. So on the Excel side, we're plugging in numbers like the size of a desk area, so 60 square feet per person, and then we're trying to figure out how many people fit into that space. So by plugging that in and then being able to modify the floor plate, we can very quickly tell how many floors it's going to be. So this is just like a 1-hour kind of test study that we do.
Yeah, you can study test fits, blocking, stacking, adjacencies. This is a piece of that script where you can take that section diagram as simple as floors and text and actually start moving departments around, and it maintains the same program area and restacks the building. So it gives you a lot of flexibility when you're working in a workshop scenario to be able to say, well, what if we put this up here to connect if you're tying into multiple buildings, this, that, and the other, and you get a really good understanding of just a general floor plate size and key adjacencies.
And there's 2 sides to kind of work this problem. Is there's either you're automating it so that the rooms are stacking, or you're manipulating the geometry and then you're getting a result of how many people fit in that space. So in this scenario, we're manipulating the geometry, and whether we're adding the floor or changing out the amount of people, green means it's within tolerance of how many people we're trying to achieve, and then red means that we're just way off.
Yeah, it's like a design program check, right? So we're designing this stuff in real time. We have some program numbers that are pretty fixed, and we want to be able to get real-time feedback and not push too far in one direction without getting some analysis ran. So it's lessening those feedback loops, not by design phase, but more just by the iterations you're actually working in.
So now cost, like I was saying, so cost and people are like the 2 things that we deal with on every single project. So this is kind of been like a work in progress. We've used this on quite a few projects now, something we've developed over this last year, but custom heads-up displays for the project. So finding the information that the client and the team is most interested in and getting that displayed on the heads-up display, and then being able to modify that as the building modifies. So this is a completely interactive model, but just kind of showing what the dashboard is. So at the top is the cost per level, and then we have a couple of facade options here. And then these are some target project costs, like breaking out fit out versus department, some site and connection options. And then we have a couple multipliers, and then we have the total project costs, and then we have owner costs, and then the grand total is on the lower left. And then on the upper right, we have key attributes like all the large add-on items like the elevator or some of the site infrastructure, things that can be tied into a floor, but tend to be options. You can kind of toggle them on and off for the building. And then we get the square footage per level, and then a big thing here is the BOMA calcs. So this was kind of interesting how we noticed the developer was working with our documents is they would always want, even from the early stage, they would always want CAD drawings, and then they would spend a week to run their BOMA calcs. Well, as for us, it's a pretty simple operation to do because we're just associating certain geometry with certain items for both the overall building and then per floor. So for us, we can just manipulate the building as long as we're modeling in a fairly structured way. Those BOMA calcs just take a second to run out.
Yeah, we use this on another project to look at phasing. So that becomes really important when you start talking about a project where the client has a long-term, a 10-year vision of several different pieces to one overall project. But how do you start phasing this from the cost-effective manner? What key infrastructure pieces need to come in up front, which is where you can start looking at these key attributes. So you can focus it on overall breakdowns, or you can focus it on phasing, which is really great. It's all tied back into an integrated process with the contractor. Really, it just involves sitting down and understanding what the key metrics we need to measure are. So for this, the BOMA calcs are really important. For healthcare, it might be how many inpatient beds can we fit per phase, and what's that cost impact going to be.
Yeah, and then sometimes this dashboard is changing throughout the project, so we set it up really basic. Maybe it's just purely looking at square footage in the first workshop, and then we start adding on more and more stuff to it as we go. So this was developed as we were working on a IPD project. So, in the room, when we have the contractors in the room, we have all our team partners in the room, like getting access to the information is really easy, but being able to work on it all together is a little bit more difficult, especially from like early on stages in the project. Because it's a huge challenge because we have all these different models that we're testing, we're taking off floors, adding floors, and being able to get that information to the contractor to be able to start to run some of their numbers on. And so what we ended up doing is, we tied in that Excel sheet. So right now the model is we're toggling off all the items in the model to kind of get it down to 0, and then we can see like per level. And then the Excel sheet is it's an Excel sheet that just lives on the network, so the contractor can just access it and make sure all the numbers are correct, and then we're just pulling from that straight into the Rhino model.
And from the client side, it provides a real transparency to the design process because they can actually see that everyone is integrated. We're utilizing something that the contractors filled out that they verified that they're comfortable with. And, on a project like this, we've actually had a separate cost model being ran simultaneously as our interactive display, and it's actually coming back where they're tracking in the exact same direction. So it's a lot of verification that the communication is there, and it's also enabling that communication to a much greater degree.
So this model is not a dead model. It's not a viewer. This is completely our working model. So in this demonstration here, we're going to be just adding a floor and then splitting that floor and making half the floor a green roof. So you can see, as you add on the new floor, you get a new level that happens up on the top here. The grand totals updating. It updates the project costs. We're swapping out the type of floor. So that's all. You kind of live in this world for a while, especially on large projects of it's just purely two-dimensional geometry, and we're trying to determine what department is which, and each one of those departments has a different cost.
Yeah, there's something nice about this being still in that design model where if the designer wants to sketch over the facade, we can still make changes on some of the other stuff, update the facade, everything comes back in real time to get a really good understanding of what is the actual impact of that change from, stepping back, what's the structural impact of this change, what's the cost impact of this change, these key metrics that we're measuring, we're getting that feedback in real time, and it's incredibly valuable. I mean, our design teams on several projects are using this on a daily or, several times a week at least to back check all this stuff. And when you're working in concept design and you've got 15 options you're producing, you can now compare them all across the same set of metrics, which is incredibly valuable. Yeah,
so the one thing we're not showing here is like in a workshop scenario, this will be up on either projected up on a wall or up on a big screen, and then there'll be either Joel or myself or someone else that's kind of working the kind of the background on the scene of whether it's just changing out the geometry or updating the code.
Yeah, we've had situations where the owner was in the room trying to figure out how he could get the phasing down to meet a certain number and still get the building to have the same gesture he liked, which was a really great opportunity to kind of showcase the fluidity of the tool. And it's been something that, based on that experience, has led to further development, and now we have a lot more refinement to some of the heads-up display parts.
Yeah, because there's certain things that, you know, the client thinks that's going to take out a lot of money, like taking out an atrium space.
Right.
But purely just taking out the atrium space alone doesn't eliminate any costs. It's unless you make the building smaller is the only way it's going to eliminate cost.
Yeah, and we always watch for the contractor's reactions to those changes, because if they start sweating a lot, then we know we should really tailor it back. But for the most part, they've been pretty good about it. Stepping into some of the stuff that is a little more in my background is actually we're starting to roll really rapid daylighting and energy analysis into these models. So this is actually looking at the same 5 options we were comparing from a structural standpoint, and literally taking that exact same model and starting to run daylighting analysis on it. So we're getting a really basic understanding very, very quickly in a matter of, you know, half an hour. We can run this analysis, get an understanding of continuous daylight autonomy. We can tie lead metrics into this. We can understand if we apply a certain percentage as a variable to the floor plate, how much daylit area we have. And it gives us a really good understanding of, okay, well, we've looked at cost, we've looked at structural impact, we've looked at all of these different metrics. Now let's start to roll in some of the performance metrics, which a lot of clients are demanding that level of analysis now, especially early on. And one of the things I always like to say is, you know, some of the most important design decisions from a sustainability standpoint are usually made in the first 2 weeks of a project. So the faster we can start to understand those, the better. This is another part of the workflow where we're just developing a matrix. This is a fully parametric matrix where we can start with a single shape or shoebox model, apply different parameters as far as building program, program area, size, footprint, like all these different ratios, and generate a matrix that looks at window to wall area ratio and building orientation. So we can actually false color the information, run analysis on it that's based in Energy Plus, so it's a pretty solid base for the analysis engine. And it actually gives us feedback. I think it takes about 1 to 2 minutes to actually run for the entire set of buildings to get a really high level understanding of EUI. So we're actually starting to calculate EUI in the first, you know, couple of days of a design process. We're given a site, we can start to inform the design direction just using a computational approach. So you're starting to see you can now toggle different buildings, they get false colored based on energy use intensity. It's a really great way to start rolling analysis on top of everything else that we're doing.
The amount of these tools that have popped up in the last 5 years is kind of incredible.
It is.
There's been a lot of add-ons for Rhino and Grasshopper and Revit as well too. It seems like 5 years ago that I think the only thing available was like Ecotect.
Yeah, 5 years ago I was doing this like in a lab somewhere, because the only way you could justify a lot of the daylighting analysis was you had to have a render farm, you had to have significant time, you know, you had to have people that were trained in a very specific software. It's almost like computer science. And now we're being able to teach a process that enables you to look at cost, analysis, building performance, massing, and design simultaneously. So you're providing value across all of those fields without sacrificing the project timeline or budget, which I think is really valuable at the end.
So interoperability, I think I could probably do a 30-minute presentation just on interoperability. So, you know, today we've talked about design, we've talked about analysis, and then finally workflow is a big thing. And it's kind of the 3 main things that we've been doing with computation. So with interoperability, there's a ton of different ways to do it. Again, you know, especially in the last 5 years, there's been all kinds of ways that popped up. This one, we're using Rhino with Revit and Dynamo. It's a plugin that's developed by Nate Miller, Proving Ground. And we use this workflow a lot. It's really easy to set up. It looks complex. So on the far left, we have the Rhino model. Then we have the Grasshopper model, and then we have Revit, and then we have Dynamo. You kind of need all 4 at once to kind of create this streamline effect. You know, anytime you're bringing geometry into Revit, the biggest problem is that geometry has to know what it is. Right. So we have to assign, you know, we use Grasshopper to assign some of that data, and then we use Dynamo to pick it up and then push it into the Revit space.
And one of the really crucial things about this, and one of the focuses that Matt and I have had at HDR, is developing these things in such a way that they're not custom to every project. So we're developing it more from an approach of taking like the template. So if you have certain items and aspects of things that you know are going to be repeated across projects, then we're leaning up our own process, which has been a big topic of conversation, to be more efficient as design teams get smaller. If we can provide tools and packages of tools that people can sort of plug and play, where there's minimal overhead and training involved in teaching that, it shows a real value to the approach overall.
So again, going further on the same workflow, but with the facade. So two main things we tend to see with interoperability is floors, just getting all the floors in there really quick so that people can start dropping in walls and rooms and all that. And then facade is a big one because a lot of times if we develop the facade in Rhino, we just need a representation in Revit just to kind of move things forward until the floor plates start to settle down. And one of those workflows is with Rhino. So in this case, we're using an adaptive component, a really simple one for this project right now because we're just kind of getting into design development. But these workflows are super easy. On our end, we just have a couple templates set up. So for a project team at HDR to kind of get up and going on it, it's like a 5 or 10 minute setup. So
yeah, I mean, you can start from scratch and start rolling these things out in half an hour to an hour, which is great for us, being it's an international company. So if somebody in San Francisco needs the work, we don't have to fly all the way out there. We can have a phone conversation, send the files, walk some people through. And again, you're teaching people on that end as well. So it's solving for a need that they have and giving them an additional level of knowledge. The other great thing about this, and we'll get into sort of the data mining stuff in a minute, is you can start to, in an integrated approach, you can start assigning costs to every single one of these Revit elements, doing quantity takeoffs and all the stuff that we're already pretty familiar with. And you're getting that feedback that's necessary in that production model.
So Revit and data mining. So this is another one. It's kind of like interoperability. There's a whole bunch of different ways you can do this. One of the ways that we like to do is using Dynamo, just because it's customizable. It's really fast. Of course, it depends on kind of what stage of the project you're at. As the project gets more and more developed, I think we're probably familiar with all these, but Affinity. T-Rofus, BIMLink. Yeah. There's a ton of different ways to do it, but like I was saying, with Dynamo, we can pull stuff out of the model like super quick, and we can pull it to various databases, whether it's Excel, Access, SQL. And this one's just pulling out floor plates and panels right now.
So depending on the format that the data is being asked for, if they're not asking for a model, they're just like, oh, we want a summary of these key spaces with these key metrics, we can start to customize our Dynamo scripts to pull that information out. So you're not having to just extract every bit of the information. You're doing a little bit of pre-filtering and being able to give someone what they need and not more, which gives us a lot of flexibility on our end.
Yeah, I think P3 projects were mentioned a couple times today also, but we use these a lot on P3 projects because the size of the programs is huge, and they got to be like dead on, like 1% off. So it's like very, very crucial that every room is accounted for and that they're within tolerance. So being able to push the information out really quickly, verify it, and then push that same information back into the rooms and start to get that variance as a parameter.
Yeah, and we've actually taken that parameter variance and assigned it to color templates. So we're able to visually look at a model in 3 dimensions and understand what rooms are over, what rooms are under based on these certain percentages. So the design team, without having to track down, what room is, the 1001 or on this level, you can graphically have a really quick understanding of where your problems are and start to have a better understanding of, we've got to change core and shell, we've got to move some things around, and here's why.
So one of the things we can't do in the Revit environment that we were doing in the Rhino space was we were creating all the heads-up displays, which was really great for being able to work fast, work with a lot of people at once. A little tougher to do in the Revit space, and is why we've kind of got into the working with Power BI.
Yeah, and one of the great things about Microsoft Power BI, if you're not familiar, is it can be cloud-based and it can run on multiple platforms. So that Excel spreadsheet that was generated using Dynamo or any other software you would need depending on the phase of the project can get pushed into Power BI as just raw data, and then you can start making an interactive dashboard that starts to highlight key building elements. So this could be pushed out in a read-only format to clients or owners, subcontractors, anybody on the design team, so they can get an interactive understanding of what's in the building data. And this goes back to you find the key metrics that everybody wants to study, and you can build a dashboard around those key metrics and say, okay, well, we can start looking at trade-offs, we can look at phasing, we can look at area, we can look at occupancy. You can also ask it questions, which this is really fun. You just type in, occupancy this, or how big is my building, and it will actually start to report back that level of data. So it's a really powerful tool, and we're consistently exploring some really novel ways of utilizing it on projects.
So that's it. So just kind of sum it up. There's the big thing for us on these projects is that how computation operates across the project. So from design through analysis and into workflow. So we get a ton of questions as to like what is computation, and is it to speed up my work? Is it to automate the facade? What is it? So
good answer, yes.
Yes to all of them.
So. Right on. Great. Thanks very much, guys. So I'm going to kick off the questioning again. So get your questions ready. So this is great information. It's great resource. As you say, in the last 5 years, it's really come a long way. Issues that I'm having in the office is getting this type of technology in front of the architects and the designers at that early stage. Because typically I get, okay, here's the design, now do the analysis on it. And at that point, it's too late.
Yeah, it's much more about validation.
So what's your experience been with pushing this forward in the environment of these traditional offices? Because you guys are working in all office sizes, right, from 20 people to 200. What's your experience been with that, with the adoption of this type of technology in larger firms and architects to smaller firms? What I'm trying to do is relate this back to everyone's to use.
Yeah, I think in some ways I kind of see it as like similar to how the programming world works. And I was mentioning this before, but in programming, once you learn to program, you don't ever just start from scratch and write every line of code. You're grabbing large chunks of code, and then you're putting that together to create, a really robust piece of software. So I think it's the same way. So we build small templates, and the teams can just grab those and run them and use them. So the training is actually fairly minimal, and then there's just a ton to be gained from being able to just grab those and use them. And then once they use them once, then it's like, oh, okay, well, you used it once, now let's use it on this other project.
Yeah,
so.
I think the goal would be, you want to find those key designers that are very receptive to the approach in every single office that can champion the partnership up front.
Right.
Just to start utilizing the template approach, and then it's taking that and it's teaching someone a skill that they might not have had before, that they can see the value almost immediately, and oh wow, I can produce 8 more iterations of a design in the same amount of time without any loss of information on the back end. So they start to think more in those terms rather than, I need 3 days to sketch this and draw this. They can be like, okay, maybe I just need a day to set the file up, and then I can crank through 15 iterations the next day. So it's pushing, at least for me, it's pushing that work onto the front end, so you're a lot more flexible throughout the rest of the process.
So is this more front-end loading of the building information model?
I think to a degree. I think some of the template setup that we've been talking about is very much front-end focused, but we're not saying that you need to have a fully functioning Revit model in the first 2 weeks, you need to do all this. It's very much just about an approach of knowing if you do it the right way first, you minimize all of that rework, and you actually give yourself time to work through options.
And there's just a lot of low-hanging fruit right now on the front end with a lot of waste.
Yeah. The waste is on the front end, and we're constantly identifying things we can do that are not as low-hanging, so to speak.
Because we didn't show a lot of it in this presentation, but there is a lot of stuff we do on the back end with Dynamo to automate certain processes.
Room data sheets. You know, one of our colleagues in Australia has developed an add-in that's pretty incredible and can start to, and using Dynamo and a couple other things, automate. You click on a room and you can automate the entire room data sheet.
Yeah.
And I think things like that is, in my mind, it's about putting design time in the hands of designers.
Yeah.
And it's about enabling mentorship across disciplines. So if you have someone that wants to learn detailing, you know, they don't need to draw the same detail 25 times over the course of 5 weeks and be very repetitive in that. They can refine it, and it's different. But it's allowing the people that want, it's enabling designers to design, and it's enabling people to learn, because you're not spending time doing something that can be automated to a degree.
Yeah.
And that's some of the more difficult tasks we're working at with the Dynamo stuff, is automating a lot of the production workflow. You know, I don't necessarily learn anything from dragging and dropping a view onto a Revit sheet
Yeah.
1,500 times, depending on the size of the project.
Yeah.
So it's just a kind of focusing that way on.
More efficient resource use of your time.
Yeah.
Is there any questions?
Hi, just wondering, have there been any efforts made in HDR to disseminate computational knowledge for other employees? Because for a long time it's been more regarded as a specialist kind of a role. There's usually, across many firms, there's the one computational guy or the one computational division, and so any kind of computational work is it's seen as a resource, and the design team will tap into that resource and have that help. But is there, what's your personal position on it? Do you think that it should remain and continue to grow as a specialization, or do you feel that there's value in educating every designer so that they can benefit, in maybe not as a specialist, but to some degree benefit from learning computational skills?
Yeah, it's a good question. One, and definitely one that we get a lot. I think the main thing that we're going after is within HDR we have a practice innovation team, and so we see a small team of people being able to do stuff that's super custom, that requires a certain set of skills, and then but then we also want a large network of computational designers that they don't need to know programming language. They just need to be intermediate level. They need to be able to take all the templates and scripts that we create. They need to be able to load them up and run them and modify them for their projects. So to me, that balance between having a really, really small team of 3 to 5 people that can generate the really custom R&D efforts and that require that extra level of knowledge.
Yeah, I mean, I would take a similar stance. My view on this, much like a lot of the tools that we show, is that this type of knowledge should be open source. So everybody in our company has access to it. It depends on their appetite for learning. You know, we're not going to come into every single office and demand that they work using this exact set of tools and these templates. But what we are going to do is disseminate the information in such a way that everyone knows it's available. And if there are individuals that want to champion it in their office, that we can then have conversations with all the right people to make sure they have the resources they need, and they have the support from local management and at a national level to buoy up the skills in those offices. Because when we elevate someone's interest, it's going to bring up everyone else around them. So I think it's exactly what Matt was saying. I mean, we want to disseminate this information to everybody equally and make sure that they know we are a resource and that they can become resources themselves. So it's just enabling that.
Yeah, good point. Cheryl?
Yeah, so interesting presentation. Thank you for coming up here.
Thanks.
So my question is about metrics and how you guys developed the metrics, how you encoded the calculations of those metrics, and also how much are those metrics specific to your firm versus specific to a project and a team? And the reason I asked that is you talked about cost, and it made me think, well, whose cost are you talking about?
Yep. So I mean, that's where I see computational designers being able to position themselves as kind of the director and the master collaborator between all these, because for instance, like the space planning one, that was, we have a whole team of people just working on space planning, but their biggest struggle is that they're in the world of Excel documents and printed out drawings, and all we did was basically merge those together. And even more so on the cost model one, that the team on our IPD projects that are doing the cost estimating is a massive team.
Yeah.
And so we're working with them. We're trying to always push them to get kind of like a summary sheet that we can then work with. Because it doesn't really benefit us to plug in every single number, but if we can plug in, whether it's cost per object, cost per square foot, different zones, depending on all that. So it can get really complex, but trying to find that the balance between, what are the summary of like the contractor's information, so that, he's not just handing over his huge document.
And it's really about, we'll go into workshops with users, owners, contractors, everybody. And it's about framing the question of what's really important to you, and that can be different on every single project. Internally, we might want to measure, well, how large was this hospital and how large of the last 10 we've done over the last, 5 months, because we want to start getting an idea about just basic sizes from a planning and programming standpoint, and starting to build a database of our own work. And that information is great, and we can use that to modify things and start those conversations. But at the end of the day, we're creating buildings for users, for owners, for other people. So we need to understand what's really important to them and have our designers have that conversation in person. So we would bring a very integrated team in a workshop scenario to say, okay, what's really important to you? And then you kind of hand that question out to the 30 people that are there. Our designers can speak about what's really important to them, and it's on us to distill that down and provide feedback and sort of challenge either assumptions they might have or learn from what they want to know from their buildings, and then create that custom content so they can see, oh, that was really important to me, and you're taking that feedback, you're measuring it, and you're showing how the building responds to
And
it.
the amount of metrics is
Staggering.
a big thing too, because if we show too many metrics, everyone's going to be confused. But the examples we showed, all those were driven by the client, so they said that they wanted to look at the numbers in a very particular way.
Mhm.
So we just went along
We've
with it.
done the heads-up displays with 3 bar charts and a single number at the bottom that says, okay, this is counts for these types of rooms, here's your overall square footage, and we've done the fully integrated cost modeling dashboard. It highly just depends on where you're at in the design process and the appetite of the client to see that type of work.
Right on. Great. So these guys are here hopefully for the rest of the day.
Yep.
So if you have any other questions, please feel free to track them down. Thanks, guys.